Right now in Santa Barbara, there's a room colder than deep space, minus 273.14 degrees Celsius. Why? Because inside it, reality breaks. This machine just did something in 5 minutes. A supercomputer would need 10 septillion years. That's a 10 with 24 zeros. Last week, Google officially killed the noisy era of computing and launched the age of error correction. This is Willow. This postage stamp-sized chip could cure diseases we haven't named. And it could also break every bank password on Earth. Forget what you know. Quantum computers aren't just faster laptops. They don't run the race. They are the maze. Willow isn't the finish line. It's the starting gun for the most expensive hardware race in human history. The race to 1 million qubits. I read Google's 2026 Willow roadmap and the quantum echoes data. Let's separate hype from reality, 60 seconds per concept. Classical computer, 0 or 1. Quantum computer, 0, 1, and everything between, at once. That's superposition, and it changes everything. Why minus 273 degrees Celsius? Because a single photon of light, a tiny bit of heat, crashes the whole computer. Qubits are that fragile.
This isn't decoration. It's a dilution refrigerator. 5 stories of layered metal engineered to reach 10 millikelvin, colder than interstellar space. 2019, Google's Sycamore, 54 qubits, noisy. 2026 Willow, 100 plus qubits. With quantum echoes, this is the leap.
Quantum Echoes is Google's new verification software. It's how they proved Willow's 10 septillion year claim wasn't fake. It verifies the math.
Imagine you're searching a library. A classical computer reads every book, one by one. Quantum Mist reads all books at the same time. Take 2 qubits, entangle them, separate them by galaxies. Change one, the other changes instantly. Scientists called it spookiest. Here's the problem. Physical qubits are drunk toddlers. They forget their state in microseconds, useless for real math. Google's Milestone 3 isn't more qubits, it's better qubits, bundling hundreds of noisy physical qubits into one perfect logical qubit. The real quantum Cold War isn't about who has 1,000 qubits. It's who has one error-free qubit. That's what Willow proved is possible. Willow hit below threshold. For the first time, adding more qubits means fewer errors. That's the moment everything changed. Nobody talks logistics. 1 million qubits needs a fridge the size of a warehouse, and enough power for a small city. This is your unique angle. The bottleneck isn't software anymore. It's materials, cooling, wiring. This is a hardware war now. Okay, enough physics. Why should you care? Because Willow just put 3 industries on a deadline: medicine, energy, security. Drug discovery today, 10 years, $2 billion. Quantum simulation, test every molecule at once. Model proteins perfectly. We could simulate a human cell, atom by atom. Personalized medicine for your DNA. Cures for diseases we can't even touch yet. EV batteries suck. Quantum computers can model new catalysts, find materials that don't exist yet, materials that let batteries charge in seconds. Fusion energy, room temperature superconductors. We need to model electrons perfectly. Classical computers choke. Willow won't. Now the scary part. Everything you do online is locked with RSA encryption. Willow is the first step toward a key that unlocks all of it. RSA security. Multiply 2 huge prime numbers. Easy. To crack it, you find those 2 numbers. For a supercomputer, that takes eons.
Shor's algorithm, a quantum algorithm. It finds those prime numbers in minutes. It breaks RSA. It breaks the internet. Experts say 2030 to 2040. But with Willow's error correction, that timeline just sped up. We don't know the new date. The solution? Post-quantum cryptography. New math problems even quantum computers can't solve. The world is switching now.
Google isn't alone. IBM has Osprey, Microsoft has Majorana, China has Zhejiang. This is the new Cold War. IBM's strategy: more qubits, faster, 433 today. Google's strategy: fewer qubits, perfect qubits. Willow chose quality. Google's public roadmap, 2026, is Willow. By the end of the decade, 1 million physical qubits, which means about 1,000 logical qubits.
1,000 logical qubits breaks RSA. It designs new fertilizers to end famine. Think of 1947, the first transistor. Room-sized, slow. That's where Willow is today. We haven't seen the iPhone yet. No, you won't have a quantum PC. These will live in the cloud. You'll rent time on them, like a supercomputer, but for reality. Blue ocean question. If 1 million qubits needs a city of power, is quantum computing green? We don't know the answer yet. Another gap. We need 1 million quantum engineers by 2030. We have 5,000. The biggest bottleneck might be humans. Final boss, quantum AI. Use Willow to train AI models in minutes instead of months. AI that designs new quantum chips. The loop starts.
For you, don't panic about Q-Day yet. Learn post-quantum crypto if you're in tech. Watch the hardware race.
So recap. Sycamore was noisy. Willow is quiet. Because of error correction. That's the entire 2026 breakthrough. Power. 5 minutes versus 10 septillion years. Verified by quantum echoes. That's not hype. That's math.
Stakes, cure disease, new energy, break all passwords. This isn't sci-fi. Google's roadmap says it's this decade. The race now. Not more qubits, more logical qubits. Google, IBM, China. The winner reshapes the 21st century. Which brings us to the only question that matters. What happens when we get to 1 million qubits?
Remember, we're in 1947. The first transistor just got built. Imagine telling them about TikTok. We can't imagine what's next. So why does it need to be colder than space? Because to touch the rules of reality, you have to remove reality first. One last time, classical is a mouse. Quantum is the mist. Willow just taught the mist how to remember where it's been.
Q-Day isn't if, it's when. And Willow just moved the when closer. Are your passwords ready? Passwords ready.
So no, Willow isn't the finish line. It's the starting gun. And the race to 1 million qubits just began. Error correction is the kingmaker. Google proved it. Whoever scales it first rules the next 100 years. That's the real war. So I have one question for you. If you had 10 septillion years of compute, what's the first problem you'd solve? It all started in a room colder than deep space. And it ends with a chip that just broke reality. Follow to watch what is next.
Hey, before you go, you enjoyed this video. Make sure to hit that subscribe button. Helps the channel more than you think. And drop a comment below. Tell me what you want to see next. Stick around. Your next video is waiting for you right here.